Welcome back. This is the second lesson recording for IM2, November 30th, 2020. So where we left off, we've said that 2x plus 4 is equal to 12 is an equation. You can also have an expression being equal to something, a very complicated expression here. Okay, so here it was equal to another expression or another number, but this time it's equal to another expression. That means you're just saying that 2x plus 4 is equal in value to 3xy squared square root of 4x. Okay, so that's all you're saying. So you can think of expression as English phrases. So fallen leaves like walking the dog is not a complete sentence, but it's just part of a sentence. While as equation is a complete sentence. So like I kicked some fallen leaves when walking the dog. So equations are always telling you something is equal in value. It's describing the equality relationship between two expressions. And those expressions can be simple, like 12, or it can be very complicated, like 3xy squared, square root of 4x. Now let's move on to another vocabulary, term. What is a term in math? Well, term is a part of an expression separated by addition operation. So anything that is separated by addition. So here we have 3x squared and square root of 6 being separated by plus sign here. So 3x squared and square root of 6 is a term. They are each a term. What about this negative 4y? Well, we can rewrite this negative 4y as adding a negative 4y, right? So that means that this is yet another addition operation. So that means square root of 6 and negative 4y, they are also um, they are each a term. So in this case, we have this is an expression with three terms because 3x squared is a term, root 6 is a term, and negative 4y is a term. They are each separated by addition operation. What about this? Okay, do you see any addition operation here? What is between negative 2 and x squared? This is multiplication. What about x squared and y? There's a multiplication. So there are no addition operation here. Okay, so that means this is an expression with only one term. Okay, what about this? Okay, so we are looking for addition symbols or subtraction symbol would work too because subtraction really is addition of its opposite. So we're looking for addition or subtraction operations. So that means we have, how many terms do we have? 1, 2, 3, 4. 4 terms. Okay? And the constant term is the 1. Okay? The constant is the one without any variables. And we call that constant. So we have 4 terms and one of the term is constant. So another vocabulary, polynomial. Polynomial is an expression with one or more terms or parts where each term is a power term of a form, real number multiplied by x to the power of whole number. Okay, let's see some example. So here is a variable x being raised to the power of 2. So 2 is a whole number, and that is being multiplied by 4. That's also a real number. Okay, 4 is a real number, and 2 is a whole number, so this is a polynomial. 3x, what about 3x? This is same as x to the power of 1, isn't it? X is same as x to the power of 1. What about 6? Well, there's no variable here. But can you think of a variable that we can put here to the raised to the power of what? X to the power of 0, right? So 6 is 6 times x to the power of 0. So in this case, it's a polynomial with 3 terms with one variable. X is the only variable. What about this? Okay, how many terms do we have? Well, we have a negative here, positive here, positive here. Those are separating the terms. So that means we have 4 terms, 1, 2, 3, 4. And how many variables do we have? We have x is one of the variable and y is another variable. So we have 2 variables. These are examples of non-polynomials. Why is this one not a polynomial? Because here we have a negative degree or negative x. So this is not a whole number. And 5x, 5 to the power of x plus x is also not a polynomial. Why? Because 5 is being raised to the power of x. Remember, it says that x needs to be raised to a whole number, and x is not a whole number, it's a variable. Therefore, it is not an exponent cannot be, is not a whole number, so this is not a polynomial. Okay, so let's do some check for understanding. So on your whiteboard, remember the whiteboard 5 that we introduced you to? Provide an example of, I want you to give me an example of expression with 2 terms. Okay. Okay, so I could give an example like 3x plus 5. It's 2 terms because there is one part here, another part here separated by an addition sign. Okay, this time an expression with 4 terms. One is a constant term. Okay, so one of them has to be a constant term. Something like constant is just a number. So I could use 5 or I could use a negative 5. So I can say negative 5. Whoops. Okay, so I could give an example, something like 3x to the power of 3 plus 4x squared minus 3x minus 5. I have 4 terms because I have 3 additional subtractions. And one of them is a constant term, so negative 5 is the constant term. Okay, what about an expression with one term with 2 variables? Okay, so we just want one term. So one thing, but with 2 variables, that means I could have something like 2x y squared. Okay, so I have x and y, they are both separate, 2 different variables. Okay, an equation with 2 terms on each side. Equation, so that means we need an equal sign and we need one term here and another term here. So separated by plus or minus, let's do plus. And one term here and another term here. Let's separate this time by negative. It doesn't really matter. Positive, remember subtraction is just addition of its opposite. So it's negative version. So I can do 3x plus 5y is equal to 4x plus 8x squared. That would work. Okay. Now let's talk about polynomial attributes. So a polynomial can be described in terms of its degree. It's the exponent of the highest power term, whereas the coefficient is number of immediately multiplying to the variables. So if you have 4x squared plus 3x plus 6, so degree is talking about exponent with the highest power term. Which is the highest power term? This is x to the power of 2. This is x to the power of 1. This is really x to the power of 0. So x to the power of 2 is the highest power. So the degree is 2. And so we say it's a second degree polynomial because the highest exponent is 2. What about this? Oh, I'm sorry. And then x squared term has the coefficient of 4. X squared has the coefficient. What is the number in front of the x squared? That is the coefficient. We call that number coefficient. And the coefficient is 4. The x term has the coefficient of, what is the number in front of the x term? It's the 3. So the coefficient of x term is 3. And the 6 is the constant term because 6 is the one without any variable attached to it or being multiplied to it. Okay, what about this example? Negative 3 to the power of 3 minus 3x. What is the degree in this case? Degree is the highest power term. Which is the highest power term? There's x to the power of 1, x to the power of 3. So x to the power of 3 is the highest term. So the 3 tells me that it's the third degree polynomial. And the x cubed term has the coefficient of negative 3. So when you're looking at x cubed term, the coefficient is negative 3. We in fact call this the leading coefficient because this is the one with the highest power term. And this is the leading coefficient. So negative 3 is the leading coefficient. And by convention, we organize the highest order term first. So here you have 3x squared plus 2x plus 1. So we arrange it with the highest degree first, followed by degree of 2, followed by degree of 1, degree of 0. And we do not write it like this. So this way, it's easier for everybody to recognize that 3x squared plus 2x plus 1 as opposed to when you just mix them all up. Okay, so let's do another check for understanding in your whiteboard file. On your whiteboard, provide an example of one variable x. Okay, with just one variable, polynomial with the highest degree of 4. Okay, so could be the variable is going to be x, so it could be x to the power of 4. The degree is just going to be 4. And I can put any coefficient. So let's put 3, negative 3. Okay, so negative 3x to the power of 4. It's a polynomial with the highest degree of 4. And then I can put anything else following it. I can put one term, two terms, or 0 terms. No more terms. But let's just put two more terms like 2x plus 7. Okay? What about polynomial with x term coefficient of 5? Okay, so this means it's looking for the coefficient, which is the x term. This is the x term here. So instead of 2, I just need 5. So I can rewrite everything as it is and just write negative 3x to the power of 4 plus 5x plus 7. Okay, so the coefficient of x term is 5. What about second degree polynomial with constant term of negative 3? So it's a second degree polynomial. That means we need at least x, oops, we need at least x to the power of 2. Okay, it needs, and there has to be a non-zero coefficient here. So it could be like 5 or any number, but we need a constant of negative 3. So I do not even have to have another term because I can just have negative 3 here. This is a two-term polynomial with second degree, two-term second degree polynomial with constant term of negative 3. Okay, what about fourth degree polynomial with x term coefficient of 1? So that means we need at least x to the power of 4. Oops. We need at least x to the power of 4 and the x term having the coefficient of 1. So that means 1x, or we could just omit that. So I could put 3x to the power of 4 plus x. This would work. And certainly you can have additional terms. It did not specify. Okay, a third degree polynomial with one term. So this is only single term polynomial. That means you need x to the power of 3, and it can have any number in front of it.